Alright, so good morning everyone. It's a pleasure to be here and have an opportunity to put some faces under some familiar names. And well, thanks a lot to Sylvain for taking the initiative to organize this meeting and to actually organize it, which is a lot of work. Alright, so basically what I would like to tell you about today is well, the view from the Caml development team in a way. Hello? Okay. Alright, so I will start with just some news on what we are currently doing, and that will be pretty short. And then I would like to describe some of the challenges we are faced with for longer term work, like in the next 5 years. Some are technical, and some are actually more questions of organization and the like. So let me start with some news. So this should be familiar to most of you. So we're currently at release 3.10, which was released in May 2007 with bug fix release a couple of weeks ago, and the second bug fix release coming up very soon. So just to remind you of the main novelties. So we have the new Caml with a major overhaul of the API, the OCaml build compilation manager, which will be presented later today. Small extension to the class and object layer, the notion of virtual instance variables that you can override in subclasses, for instance. And the mechanism for completing stack backtraces when an uncode exception aborts your program. So that mechanism was available in bytecode before. It's now available in native code as well. A couple of new ports, Windows 64 bits, as requested by one company member of the consortium, and for our PC 64-bit under macOS 10. Alright. And so we are already working on the next major release. So that would be 3.11. And it's planned, if everything goes well, for this summer. And some of the things to expect there, dynamic loading on native code. So the same API that is currently available for loading bytecode within applications compiled to bytecode will be available to load native code within applications compiled with OCaml. And well, so this is the work of Alain Frisch. First at INRIA and now at Lectify. Expect some performance improvements in thread synchronization that was suggested by Marcus Mello from James Street Capital. So there are two small language extensions that are being discussed, so we are not committed yet on them. So one is a small extension of the coercion mechanism, one that lets you go from type tau1 to compatible type tau2, and the other form where you omit the tau1 and let the compiler infer it. So in particular, Jacques Garrick has some idea for more clever inference of tau1 in the latter case. And another feature that is being discussed is the so-called private type abbreviation mechanism. So to extend the existing mechanism for private data types to type abbreviations. So basically what this in an interface would mean is, well, that T is an abstract type, so clients cannot construct directly values of type T, okay, so start with private concrete types. However, clients can coerce using this notation from T to the implementation type tau. And perhaps more importantly, the compiler and the server, the debugger, are informed that T is actually implemented as tau. So, for instance, they can print completely values of T, or the compiler can also optimize based on this representation type. Alright, and then I got one request for a new port, which is for the ARM processor under macOS. And for those of you who don't know, this is the iPhone. And the request comes from Fabrice Lefesson, who's already doing some pretty cool hacks with Caml and his iPhone. So stay tuned. All right, and to finish this section, a few words about the Caml consortium. So, well, it is still small, but it is growing. So in 2007, we went from 4 to 7 members. So the previous members are on the left, and the new members are on the right. So that's INRIA, Capital, and a startup company called Consort. And just as a reminder, well, the main job of the consortium is, well, to sell permissive licensing conditions, MIT-like, and the whole Caml code base, especially for customers who want to include it in a commercial offering. For other members, it's just a way to do sponsoring. Okay, it's fairly lightweight procedure for sponsoring. And, well, the yearly meetings of the consortium is also a good place to discuss needs with industrial users, and the needs they express are quite different from what you can hear on the mailing list, for instance, and probably from what we will hear about today. So, well, the consortium doesn't do anything else. In particular, at this point, it doesn't bring enough funds to pay for a full-time developer. Okay. So, as there are questions, let me move on to some of the non-technical challenges. So I selected 3. Well, challenge number 1 is manpower. So that's the usual question of the list. Why doesn't INRIA do this and that? So currently the amount of manpower that we have working on the core Caml system is equivalent to 1 person half-time. Okay, so in the past, it was more like 1 person full-time. So that's not much. So that includes, well, faculty and permanent positions like Damien Delige and I, and Xavier Leroy in Japan. And also, well, people at temporary positions like Nicolas Couillard. We can steal some time from him. And we all have more cutting-edge research projects that we are supposed to work on full-time. Okay, one thing to keep in mind is that Caml is the outcome of a major research project, okay, but it's not our main research project at this time. And so, well, what can this community? What does this mean for this community? Well, refrain from making unreasonable demands. And well, if you have an idea for a really cool development in Caml, well, start it yourself, organize yourself. Don't wait for us to do it. Okay. And then, we would appreciate help with various time-consuming tasks or testing. So we rely mostly on this community to do testing. So please track the CVS, please test the release candidates. So Damien Delige has a message. He's not happy about the testing that went with the last release candidate for 3.10.12, which didn't see that some C code was actually GCC specific. Okay, and couldn't compile with any other compiler. So please test. An area where help would be much appreciated is the Windows port, which I currently do on my very limited time, just because nobody else would touch Windows with a phone in the Caml development team. Okay, and well, it's not fun, and I'm not good at it. Okay, so Windows expertise will be very much appreciated. And likewise, so currently Damien and I spend some time building, consulting and distributing binary releases for Windows and macOS. Again, that's kind of boring work, and that takes some time. So if someone were to take over these, like it is currently done for the Linux binary distribution, that would be very much appreciated. And of course, we will keep up the good work with the Burger Force. That's the main way by which we can improve the quality of Caml. And then, well, I should advertise a little bit for INRIA. So INRIA is opening 2 positions of ingénieur de recherche this year. So these are permanent positions, fonctionnaire positions. And unlike many ingénieurs de recherche that we have currently, who work on systems and network administration, those 2 guys will work on developing software, developing research software, and working with scientists to do this. And that could include working on Caml and other So if you're interested, if you know someone who is interested, just drop me a line. Okay. The challenge number 2 is well, the core system versus the rest. So the core system is what we do, and the rest is everything you need to actually be able to program in Caml. And so I think many people, especially on the list, don't understand why in the target we distribute, we don't integrate everything. Okay, and well, there are some good reasons for that. Anything we add to our distribution ends up being maintained by us, basically forever. Okay, so that's a very big commitment. Everything we include must be copyright INRIA, because otherwise we cannot pull the dual licensing trick of the Caml consortium, and slows down our already pretty slow release cycles. So rather than adding things to what we distribute, I think well, in retrospect, we should have made our distribution smaller, so that it would contain only a core Caml system, basically the compiler, the runtime system, and the libraries and tools that are intimately tied to that. An example is the fetch library or the debugger, which have very intimate connections with compiler and runtime system. And well, so currently Caml P4 or Caml browser are also pretty intimately connected to the compiler. They access internal data structure. And then there's some historical baggage of libraries that we put at some point. Probably will not in it. But so what does this mean for this community? Is that well, basically we need to organize around the package and distribution or mechanic model in the style of Linux. So think of what we do as the Linux kernel or as GCC, okay, and think of what is needed as well the equivalent of a Linux distribution. And well, there are already existing efforts in this direction. So Godi is a very impressive effort towards packaging and having a Caml distribution. And so thank you very much, Gira. Well, the Debian Caml packages also are also a good example. And so from talking with some users, I get the feeling that, well, these efforts are very much appreciated, but some users would perhaps prefer a simpler, perhaps more naive distribution model and packaging model, but that would be more universal. Like would not depend on a particular version of Linux, or would even work both for Windows and Linux. And well, an example perhaps is CPAN, so what they do in the core community. And maybe that's a topic we can discuss later today. Alright, and quickly challenge number 3 is well, the burden of backward compatibility. So yeah, there are many weird behaviors in the current core Caml system. Why don't we fix them? Well, our experience shows that incompatible changes to the language, to its implementation, or even to peripheral tools, like Caml P4, for instance, just don't go down well with users. And I can understand that very well. As a user, I hate when things change under my feet. But well, the problem is that well, this precludes incremental fixing of past design error. Okay. I don't know, mutable strings, for instance, or right to left evaluation order. Or indeed, it prevents pretty much any evolution other than feature accretion. Okay. And well, that's a little frightening because you already have a big system. And well, I don't think this community can do anything about that. So let me move on to a couple of technical challenges. So I could have taken many more examples, but time is short, so I selected 2. So one direction, one obvious direction for future work is well, more type system goodness. Okay, so of course we could add lots of mechanisms in the type system to type check some programming idioms more precisely. And well, if you look at Glasgow Haskell, for instance, they have a pretty good selection of things that we could add. I believe many of those additional features, type system features, are just not worth the increased complexity of the whole language. It's kind of a law of diminishing returns for type systems. But still, there are a couple that possible extensions that store high and practical interest. So I just mentioned one, GADT, so generalized algebraic data type. So that's a small extension to the existing Caml data type mechanism, where basically you can add additional equations between types that are valid for some of the constructors. So I don't know if I have time to go through this example. But for instance, so the intent of this is to have some kind of one-time representation for types, type expressions. And for instance, if I have a type representation that is a constructor int, I actually know that it will have type int ty, nothing else. Likewise, if I have a pair, then the parameter here will be a product type that will reflect what is in the pair. And that lets you write, well, this kind of code, which is kind of reminiscent of GCaml, for instance, generic Caml, where you take a one-time representation of a type, of an alpha type, and then a value of the corresponding type. And then you can do this kind of pattern matching. For instance, here you know that x of type alpha is actually int, because this must be int, because this is int. I'm not sure I'm very clear here. But anyway, so the big picture that this lets you encode a lot more invariants about your data structures in the type system and have them automatically checked by the type system. So the theory behind this is mostly done, in particular behind type inference for the text, which is not completely obvious. So François Cotier and INRIA have been doing some very nice work on this lately. If we want to implement it, we hit a problem, which is that the type inference engine in Caml is, and the type checker for the core language is reaching its limits. So there are some old design limitations, like the fact that the type constructor has at most one equation about it, which are very limiting. And well, recursive modules are already constrained by that. Checking of recursive modules is incomplete because of this in particular. So the way the type inference engine was developed is by running incremental extensions on top of one another. And the implementation of the data structures we have are excessively imperative, which is extremely error-prone. So I believe that for before doing any major extension to the type system, we would need to implement type inference engine from scratch based on more modern approaches such as constraints and constraint generation and solving. And well, that's a huge undertaking because there are maybe 2 or 3 people in the world who really master this technology, and I'm not one of them. Okay, so François Cotier might has the knowledge. Okay, and then to finish, everyone's favorite challenge, which is parallel computation. So, well, unless you've lived in a cave in the last a year, you all know that modern hardware is providing more and more parallelism. Okay, so today we have those multi-core processors, which are small shared memory multiprocessors. Tomorrow we'll probably have more cores, but I'm ready to bet that we will lose shared memory. It's just not implementable when you have dozens or hundreds of cores. And we already see a bit of that with the cell processor, for instance, or graphics processor. And of course, clusters of machines remain the main vehicle for large-scale parallel computation. And so in general, when this issue comes up on the list, someone just says, well, all we need is a concurrent garbage collector and we will be fine. No, this is jumping to conclusions. Where the question number 1 to be asked is, what is a good programming model for parallelism? And nobody quite knows. So many people think of the Java model, which is what we currently have in Caml, by the way, which is shared memory, so shared mutable data structures, flags, condition variables. But that's a pretty awful programming model. Okay, and don't think anyone knows how to write reliable and efficient code with this model. Okay. If you think you do, you haven't practiced enough. So that can be improved a little bit, for instance, by using static type checking to make sure that whenever you access some data, you've blocked the associated block. I don't know of any language that implements this, but well, there has been some theoretical work like Abedi and Flanagan. So that makes things a little safer, but that's still a bad programming model at all. Better is software transaction or shared memory, as in Glasgow Haskell today. So basically, it's kind of a database model where you have transactions in which you can assign several pieces of mutable state, okay, and the transaction behaves atomically, okay. So everything happens as if no other thread was running during your transaction. That's absolutely not how it is implemented. So that's much more intuitive for programmers. But that remains a very imperative model of parallel computing, where communication is just done by banging on shared mutable data. And then there's my favorite, which is message passing between agents that do not share any mutable state. And that's what you can find in Erlang. And so, for instance, the join patterns are used in OCaml are also step in this direction. All right, so that's for the programming model. So as you can see, many different choices. Probably no obvious winner, this one. Then comes problem number 2, which is what needs to be done in a runtime system to support parallel computation. It depends very much on your model. So if you're considering basically no shared heap between agents, and you're using inter-process communications through some messages, for instance, then, well, you can do that already today. And actually, there's this co-thread library by Langley, which is a very nice example of how you can give nice APIs to program this kind of architecture. But of course, those inter-process communications are a bit heavyweight. The next possible step is still no shared heap between agents, but several agents can run within the same Unix process, same operating system process, separate threads. And then for communication, you can use fast data copy from one heap to another, because they are in the same memory space. But even doing just this in the current Caml runtime system needs some work, because we have lots of global state around in the runtime system that needs to be transformed into per-thread state. So I estimate we need to rewrite the 1/3 of the runtime system. And then there's the holy grail, which is to be able to share a heap between several agents if needed. And so we need a thread-side GC and probably even better a memory allocator, and probably even better a concurrent GC and memory allocator. So there are at least 2/3 of the runtime system that need to be resolved. And more importantly, there are very hard algorithmic issues with weakly consistent memory models that we still don't quite know how to solve. All right, and we're just to finish. And then we hit the problem, which is that the Caml language, as it is today, is not perfectly suited to parallel computation, in particular because it's all too easy to have global mutable state. Okay, like if you do let x equals ref of nirm as a global variable, and then you create one of the old threads that will have this x in their environment. Then basically you can have, and you assign into x in those threads, where you have basically concurrent, you have a race condition, you have concurrent access to some shared piece of data without any kind of synchronization. And that is really a problem. And so what I'm coming at is that we would need some kind of static encapsulation of state, or at least of global state, in any of those approaches. Okay, and well, that would at any rate be a big departure, well, a significant departure from Caml as we have it today. All right, so well, that's what I was planning to present. I don't know what we do for questions. We take some now or move on. But I will be here most of the day. I won't be here for dinner, but I will be here mostly the afternoon.
I've got a question concerning the internal data structure and the problem of licenses. I've worked a lot on Chameleon from Maxence Guédon, I think you know, and there is a pair in it, which is a graphical debugger. But I've got a lot of problem because it uses some data structure where the file are licensed under QPL or something like that, and you cannot link against this file, and all this trick for the license. I know it's something that has come a lot of time on the list, but cause not problem, but inconsistency in the possibility of doing something external to the OCaml suite. Just explain my position is, if you've got hyper in OCaml, there's no problem. But if you got it outside, you've got a problem, because you will have some problem with licensing. So basically my question is, how could you solve the equation of asking people to do something external without the help of INRIA, and having some issues with licensing when you try to make something complicated with Caml?
Okay, yeah, so the question is about licensing and whether, and observation that it can complicate some of this, well, some contributions by the community. So, yeah, well, in the picture I tried to draw, there is the core system here, which is copyright INRIA and have our weird licenses. And then there's everything else, which is copyright, you never contribute them, and have whatever license you want. So yeah, there are some, well, you took the example of the hyper debugger. So yeah, the debugger is one example of a piece of software that is intimately tied to the core system. So well, there are several ways to go about it. So well, hyper currently is copyright INRIA. So
yeah,
basically we can, I mean, within INRIA we can try to solve that issue. Just because we are the copyright holder of the two pieces of code, that helps a lot. So another direction, but well, that would be quite a bit of work, would be well, to have cleaner APIs for tools like debuggers or Caml P4 or Caml browser. And well, maybe, yeah, I don't know exactly how much of the system hyper needs. Okay, but yeah, so basically trying to have interfaces, clean interfaces. Okay, and then well, the third solution, so for people who really, well, especially industrial users who really have problems with our licenses, is just membership in the Caml consortium. Okay. Other questions?
In which direction are you leaning with your parallel?
Well, I don't know. Well, my personal taste goes towards message passing. Okay. I don't like the idea that well, we should communicate by changing shared mutable data structures. Kind of a philosophical point for me. So yeah, I like message passing because it makes communication very explicit. and forces programmers to really encapsulate where their sequential computations. And also because there's lots of nice theories behind it, process calculi and the like. So we know, we have many tools to reason about programs written in this style, which is good. Now, I'm aware there are limitations. For instance, if your parallel computation is basically parallel updates in a big database, or in a video game, for instance, the state of the world, okay, physical state of the state of the virtual world, okay, and then you want to have several files that update it concurrently, then message passing is rather bad because well, you will have bottleneck. Okay, if everyone sends update messages to a single process that manages the shared data structure, you have a bottleneck. Okay, and so this is one scenario that where basically message passing is not very good, and where, for instance, software transaction or shared memory works much better. So I guess that's pretty much all I can say at this point. Yes.
One question from someone in IRC. I'm transcribing.
Wow.
Are you actually working on a new type infer actively?
No. No, that would be at some point that will be needed, but no decision has been taken, and even no preliminary exploration work has been done.
Other stuff that's not an actual question, that's just a remark. I'm somewhat involved in the design of JavaScript 2, I mean, a new generation of JavaScript, and they are also wondering, I think basically the same questions about concurrency.
Yeah, I'm not surprised. I think everyone is challenged.
So far, they are leaning towards message passing.
Okay,
but
well, that's good to know.
You don't have to talk about OCaml P3L. Do you think it could be a good idea concerning parallelism?
Well, actually, so I think Bentley's code-file
Yeah.
library came out of this a little bit, and then Lang worked a lot on P3L. Well, so maybe you should ask him directly.
Well, in fact,
but so from what I know about OCaml P3L, so yeah, it's a very reasonable programming model. Well, it's somewhat restrictive. Okay, it's not any kind of parallel computation can be expressed in those skeleton style. But for those computations that can be expressed in this style, it's pretty neat because you get kind of correctness guarantees. Okay, that your code will run the same sequentially or in parallel, and then you get several implementations. There are many different ways to implement those skeletons that can take advantage of whether you're in a shared memory context or in a regular cluster or a supercomputer or whatever. So if the problem fits the model, I think it's a good model. Yes.
So just how many parallelism at the API can we have in a single system? Is it possible to have like OCaml and Caml P3L in the same system? Is it possible?
That's a good question. I didn't think too much about this. I'm pretty sure, for instance, if you have, if you have any kind of message passing, you can implement OCaml P3L on top of that pretty naturally. So for OCaml, it's a little bit more subtle. So if all you have is basic message passing, as in Erlang, it's just you block and you receive, and but you cannot offer several receives and several sends at the same time. Then it's going to be hard to implement OCaml patterns, join patterns. Okay, I'm sure there are implementations, but they will be inefficient. So maybe So maybe joint patterns need to be primitive, or at least something in between, just simple receives, blocking receives, and full joint patterns. But yeah, that's a good question.
There was a post on that because in the latest Glasgow Haskell compiler, there's data parallelism model that has been implemented. This weird thing that it's netted parallelism, so that it uses purity of Haskell functions. This is not correctness in all this complicated. The idea is that there's plenty of ways to do parallelism, and we don't really want to choose a way. You were talking about games just before, which is another example. There's always bottlenecks that when we want another model, and possibly mix several models in the same program, I guess. So,
yeah, these are good points. Fully agree with you. Other questions?
Another decent question. Okay, I'm not sure it's actually a question, but let me quote. It's from Christophe Kramer. I have been struggling to add support for relational algebra to the compiler. If the type system was more flexible, it would be easier. It's good to hear that you're at least thinking about that for a type system.
Okay, yeah, I don't quite know what he means by relational algebra. So,
I'm not sure.
I had one question. You're talking of message passing as a mechanism for parallel computation, but what provision do you think we could have for type-safe message passing?
Okay. Yeah, well, what I had in mind here was typed channels. Okay, so and well, as long as you're starting with one program that has been type checked and then contains several agents, processes, whatever, that are going maybe to go on different processors or different machines and then communicate. So if you are in this model, communication will be type safe by construction. So what is more subtle indeed is now if you have separately compiled programs that want to communicate using message passing. Well, there have been several proposals to make basically input value type safe. Okay, so there was one in Caml. I know also Michel Moni, Chailloux, and Grégoire Henry are working on another. That is pretty close. And then people at Cambridge, also Wellstein. So basically they all have the same idea that well, when you do output value, you're going to send a compact description of the type of your data structure so that you can check it at input value. And then there are various, well, details on how fine-grained you want this type checking to be. So I think it is possible, and I believe we could already have this. It's just the proliferation of approaches. I mean, why is there 3 different approaches? So I'm kind of waiting for one to emerge. Okay, and maybe that's maybe one thing that this community could do. Try to, instead of proposing 3 different ways to do the same thing, try to agree on one. But yeah, you're right. This, I guess this is something that could be added in a relatively short term.
You need to choose one of these, or
yeah, I know. So. More questions? Okay, thank you.